Hey, what's up guys? Welcome to a WebAssign problem. This time it's dynamics fluid problem, which says piston 1 and 2 respectively have diameters of 0.25 inches and 1.4 inches. We must determine now the magnitude of the force in pounds needed in order to support the 500-pound weight. So now let's comprehend the problem a little bit more, which in here we've got our system. It's our little piston system conformed by two pistons, which is 1 and 2. We've got this little arm in here, which will get a big force in here. And so we could draw this arm in here. And we've got a distance here of 2 inches. And then we've got a distance here of 10 inches. Now, the force in the distance of 2 inches would be F1, which is here a 90-degree angle, as well as here, but now it's F2. So then we must sum up these forces in order to get the major F, like the bigger force, right? Because we must sum both of these guys. Now, there's this formula that says, hey, if you've got force 1, you've got divided by the area 1, then we've got a force 2 divided by A2. So this, which is in the force in the area of piston 1, would be equal to the force divided by the area of piston 2. Right here, we've got 1, 1, and 2, and 2. So we've got F2, which is 500 pounds. Also its area, which is 1.4 inches. We're talking about diameter, so we don't have exactly the area, but we can operate it. And also we've got area, we could obtain area 1. What we don't have is force 1, so we must clear all this in order to obtain it. So we've got F1 would be equal to F2 times A1 divided by A2. Now, the F1 is here 500 pounds. It's right here, 500 pounds. Times the area 1, which is pi, times the radius, which is the inches in here that we've got, divided by 2, because we've got a diameter, right? And so it is 0.125 squared. This would be all divided by the area number 2, which is also pi, times 0.7, which is the half of the diameter, the radius, 0.7 squared. Now we could eliminate this pi and pi. Remember, we've got here inches, and also here we've got inches. They get eliminated. And so now we've got just this simple operation, which we will plug our values in the calculator. We've got now, which gives us 15.94 pounds. 15.94 pounds. Now, this is not our final result, because now we must get this big F. We've got this F right here, and then we utilize this cool little formula, this cool little theory that says, oh hey, the force of the torques in here would be equal to 0. But then we've got that the T is equal to the force times the distance times the sine of the angle. Now, what we must get now here is that we could utilize this formula. We sum equal to 0, then we get the value of f2, which is exactly what we're going to do here. And we've got here that f1 times distance 1 times sine of the angle, which is 90 degrees in here. So this turns into 1. And then we've got to put minus f2 times the distance 2 times the sine of 90 degrees, which is also 1. This will be equal to 0. Now, if we put this negative in here, when we do our little f2 equals to something, we'll get that there's a minus in here and there's also a minus in here. So both signs will be cancelled. So we get a positive force, right? So then we've got to clear f2 because f1 is right here, 15.94. So then it is minus f2, which would be equal to this guy, f1 times d1, which is positive here now, goes to the other way in negative, which is f1 times d1. And now this would be divided by the 2, which is multiplying here, which is d2. Now this negative and negative, they get cancelled. So now this is f1, this is 15.94 pounds. The conversion with what we're gonna do with the units, it's exactly the same that happens in this place. This segment, which is pounds, then we get inches divided by inches. You'll see now. So this is 2 inches because it's distance 1. But now distance 2 is the sum of distance 1, which is here, and this guy, which is 10 inches, right? So it's 10 plus 2 inches, which is 12 inches. It's right there. Now we've got the inches and inches get cancelled, and if we plug our values into the calculator, we'll get a value of 2.66 pounds.